Good afternoon, everyone. My name is Jiajun Chen, and today I'm going to present my research working with my mentor, Professor Radi, and the topic is called Metal Surface Designs based on Machine Learning. And the general goal of this project is to design a metal surfaces with required electromagnetic properties, but more specifically, the property is the reflectance value of the light. And here is an overview of the metal surface. And in this project, all the light is sent perpendicular and strike at the metal surface. And most light will bounce back in all directions, right? But we are only going to measure the reflectance value of the light in a particular direction. And the angle between that direction and the vertical axis is called θ. It's one of the parameters we have to set later. And here is the metal surface structure, and we can see we have shift parameters and SWA and SWB parameters. Those are the three geometry parameters we are going to need to determine the structure of the metal surface, right? Yes, right. And the method we are going to use is called machine learning. And on the left side, here is the structure of the model. And we are going to feed the input data into our model, which consists of two values. And the first one is θ, which is the angle. And the second one is the reflectance value of the light. After going through all those layers, the model will give its output as three parameters: shift, SWA, and SWB. Those are the three geometry parameters. And just in case you forget it, I've also put a diagram here: shift, SWA, and SWB. And we have generated 879 samples so far as training data. Training data means we are going to put those data into our model in order to train it. But we also generate 105 samples as validation data. Validation means those data cannot be seen by a model. We are not going to put those data to train our model. And those data is used to evaluate the performance of our models. And the software I'm using is called CST Studio Suite 2018 to generate those data. It takes literally like 40 hours in total. It is a long time. Okay, and here is the result I get. The result is not bad. And you can see we have training loss and validation loss here. And loss basically measures the differences between the predicted output and the truth value of the label. So here it is. As you can see, as the training goes on, the loss decreases, and eventually it comes to a steady value, which is like 5 approximately. And here is the graph that I measure the differences between corresponding to each individual geometry parameters. And we have shift, SWA, and SWB. And we can see the shift parameter is doing much better than SWA and SWB, which is close to like 20% error only. And we have SWA, which has 50% error as training goes on. But the model does not get a very good result. There is definitely space to improve it. And here is a quick demo I can show how this model works. You only need to input the reflectance value and the θ angle, and the model will quickly give back to you the results of those three parameters, geometry parameters, shift, SWA, and SWB. And the future goal we want to pursue, of course, is to build a more accurate model, right? So the first thing we need to try is to generate more data. Right now we only have 1,000 samples only, and it is not quite enough even. We want to expand the data size to 10 times larger at least, right? And as more data, we can add more parameters into the model, because more parameters means the better ability to to generalize the linear relationship between the input and the output. And of course, we want to apply other fancy technique, like apply other layers instead of using linear layers all the time, like dropout layer. We have dropout layers, convolution layers, and other stuff like that. And in the end, I want to thank my mentor, Professor Roddy, for his continuous support, and as well as all the staffs that have contributed to run this wonderful program. I have to admit that it is one of the best experience I have gotten so far. It is amazing. And here comes the question section. Feel free to ask me.